Okay, hello Cloud Gurus and welcome to this lecture. So we are going to summarize everything that we've learnt in the high availability architecture. You've done really well to get through this section of the course. It is one of the most challenging. The only one that's more challenging is the serverless one, which is coming up. So what did we learn in this section of the course? Well, we learned there's three different types of load balancers. If you remember the cars example, so we have our application load balancers. They're layer 7 aware, and they're pretty much what you typically would want to use in production because they can make intelligent routing decisions. We then have our network load balancers. So just remember the Tesla Roadster. This is where you need extreme performance or perhaps a static IP address. Network load balancers are not application layer 7 aware. They only go up to layer 4. We then have our classic load balancers. These are basically where you want to keep costs under control. You don't need intelligent routing and you just want to keep your costs down. So we have the three different types of load balancers. Remember what they are and their use cases going into the exam. Now in the lab, when we were rebooting our RDS instance, it caused our site to go down and we got a 504 error. And this means that the gateway has timed out. So our whole web application is not working. And it could either be our web servers or our database servers. In our lab, it was our database server that stopped working. So just remember that a 504 error means that the gateway is timed out and you need to figure out what's going on with the application. Is this the web server layer, the application layer if you've got one, or database server layer? Moving on, we learnt about with classic load balancers, if you need the IPv4 of your end users, you need to look for the X forwarded 4 header. We then also learned that instances monitored by Elastic Load Balancers are always reported as either in service or out of service. And you can put health checks, which check the instance's health by talking to it. So we did that with the healthy.html file. And then load balancers always have their own DNS names. You are never given an IP address. And by that, I'm just talking about application load balancers as well as classic load balancers. You can get a static IP address for a network load balancer. I would recommend that you go and read the Elastic Load Balancers FAQ. I say in the slide for classic load balancers, I'd read the FAQ for all load balancers. You're going to get about 10 questions on your exam concerning load balancers, and a lot of them are just going to be scenario-based questions as to which one you should choose. You might get a question about gateway timeouts, so if you've got a 504 error, and you might get some questions on, using a classic load balancer, how you get a public IP address. Do you remember? It's using the X forwarded 4 header. And then if you want a deep dive on application load balancers, I appreciate we just went over it in a very sort of high level. We definitely have a deep dive course on the A Cloud Guru platform showing you how to create super intelligent routing decisions. We then went on to learn about advanced load balancer theory. So we looked at sticky sessions, which enable your users to stick to the same EC2 instance, and this can be really useful if you're storing information locally to that instance. We also looked at an exam scenario where essentially we weren't getting connections to another EC2 instance, and the way to enable that was to disable sticky sessions. So sticky sessions can come up in either sort of scenario. We then looked at cross-zone load balancing. This enables you to load balance your traffic across multiple availability zones. And we looked at a scenario where essentially we're having issues where traffic wasn't being routed to a particular instance in another availability zone, and that was because we didn't enable cross-zone load balancing. And then we looked at path patterns, and this allows you to direct traffic to different EC2 instances based on the URL contained in the request. And we looked at myurl.com was going to our web servers, whereas myurl.com was /images was going to our media-based servers, which were in a separate availability zone. And then we looked at CloudFormation. CloudFormation is a way of completely scripting your cloud environment. And then we also looked at Quick Start, which is a bunch of CloudFormation templates already built by AWS solutions architects, allowing you to create complex environments very quickly. And then finally, we looked at Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS cloud without having to worry about the infrastructure that runs those applications. You simply upload your application, and Elastic Beanstalk automatically handles the details of capacity provisioning, load balancing, scaling, and application health monitoring. And I used an example. Elastic Beanstalk really is aimed at developers who just want to get their stuff into the AWS cloud quickly. They don't want to have to go and learn something like CloudFormation. CloudFormation is way more powerful than Elastic Beanstalk, but again, it takes an awful lot to learn it. And if you do want to learn CloudFormation, of course, we have an advanced CloudFormation course on the A Cloud Guru platform. Moving on to Bastion hosts and how we can have Bastions highly available. We had two different scenarios. So we have two EC2 instances that are in public subnets. We've got an EC2 instance in a private subnet. These two EC2 instances that are in the public subnets are in different availability zones. We have our network load balancer, and essentially you're SSHing or RDPing into that network load balancer using a static IP address. It's then load balancing between your two hosts, and they then connect back into your private subnet. And if there is any sort of loss, let's say one Bastion host becomes unavailable, there's going to be health checks done by the network load balancer and traffic would be redirected. And that's typically what you would use in production. We then had scenario 2, which is where we've got one EC2 instance across in one availability zone, and then we have it behind an auto-scaling group with a minimum of 1. And essentially what you're then doing is you're SSHing into your Bastion host, and then you're connecting into your instances in your private subnet. And then if this Bastion host becomes unavailable, what will happen is your auto-scaling group will spin up a new Bastion host in a new subnet, and then you can use a user data script to grab the elastic IP address, and then your users will then be able to connect in via this new Bastion host to the EC2 instances in the private subnet. This is not foolproof though. You will have some downtime, and that downtime is limited to the amount of time that it's going to fail the health check, and then the amount of time that it's going to take to provision your EC2 instance. So just remember that going into your exams, the two different scenarios with high availability with Bastion hosts. You've got two hosts in two separate availability zones with a network load balancer and a static IP address, and health checks to fail over from one host to the other. The reason you can't use an application load balancer is because it's layer 7 and you need to use layer 4. And then we also have one host in one availability zone behind an auto-scaling group with health checks and a fixed elastic IP address. And if the host fails, the health check will then fail and the auto-scaling group will provision a new EC2 instance in a separate availability zone. And then you can use a user data script to provision the same elastic IP address to the new host. This is the cheapest option of the two scenarios, but of course it's not 100% fault tolerant. And then finally, the thing you need to be aware of is what high-level AWS services you can use on-premise for the exam. So we looked at database migration service, server migration service, AWS application discovery service, VM import and export, and always remember that you can take a little piece of EC2 home with you to your own data center. You can actually download the Amazon Linux 2 as an ISO and then mount it on whatever hypervisor you decide to use, so it's such as VMware or Hyper-V, etc. So that is it for this section of the course. You've done really, really well. If you've got the time, please join me in the next section. Thank you.